Hi, a very good morning to Dr. Ama. My name is Chung Zi, metric number 291960. We are from Group 1, and today we will be presenting the BP Deepwater Horizon disaster, which happened in 2010. First of all, I would like to give a short summary on this world's largest marine oil spill. On 20 April 2010, the Deepwater Horizon rig, leased by BP from Transocean, suffered a blowout while drilling the Macondo well in Gulf of Mexico. Before the blowout occurred, the rig was already experiencing several critical weaknesses. First, there were major equipment and system failures. The gas alarm on the rig had been disabled, meaning that workers would not be alerted if dangerous gas levels were detected. The drain control computers also crashed frequently, affecting monitoring and decision making. The rig had not gone to dry dock for 9 years, and an audit had identified 390 overdue maintenance tasks, requiring more than 3,500 hours to work to repair equipment, update safety systems, and complete essential maintenance that had been postponed. Second, BP made several unsafe and cost-driven engineering decisions. They chose the long-string casing, which was cheaper but provided fewer safety barriers. Only 6 centralizers were installed, even though Halliburton, one of the world's largest oilfield service companies, recommended them to use the 21, but they didn't hear. Halliburton's model had also predicted a severe gas flow problem, but this warning was also ignored by BP. BP also did not install a lockdown sleeve, which would have added another layer of protection to the well. Third, there were weaknesses in operational procedures. The team performed only partial mud circulation, about 30 minutes, instead of the usual 6 to 12 hours needed to detect the gas influx. In addition, the cement bond lock test, which checks whether the cement has sealed the well properly, was also cancelled by BP. Even though Halliburton had warned that the cement job might contain channels or gaps, BP still proceeded with the cementing operation. All of these issues combined significantly increased the risk of the blowout. As a result, these combined weaknesses lead to the explosion that killed 11 workers and caused the rig to sink. The damaged well leaked nearly 5 million barrels of oil over 87 days, making it the largest marine oil spill in U.S. history and triggering major environmental, economic, and regulatory impacts.
A very good day, everyone. I'm Longnath Sivakaran here. My metric number is 297579. As for today, I'm going to present on the short summary of this incident and its corporate impact. As for the summary, the Deepwater Horizon disaster has occurred in April 2010 when the BP offshore drilling rig exploded while sealing the Mokoro well. When the blast killed 11 workers and caused a massive structure damage, leading to an uncontrollable oil leakage that lasted 87 days. It becomes the largest oil spill in the US history and resulting from a faulty safety decisions, ignore warnings, weak risk communication, and a culture that prioritizes speed and cost saving over safety operations. As for its impact, the Deepwater Horizon disaster severely impacted the BP at every corporate level. More than the company faced than the 60 million in fines, compensation, and cleanup costs, causing a major fall in share price and damaging its investors' confidence. Moreover, BP's reputation suffered globally, be it the public, regulators, industry experts, viewing the company has a weak safety practices. Government-imposed strict offshore drilling regulations, increasing operational costs, delaying projects may impact directly to related to ABC model, which stands attitudes, behavior, and culture. As in attitudes, BP leads a prioritized cost and speed over safety. So behavior is leads to the shortcuts, ignore warnings, and also an unsafe operational decisions. As for culture, over time, BP developed a culture that normalizes risk and tolerate unsafe practices. This negative chain from attitudes to behavior to culture ultimately shape the BP's corporate identity and contribute to the long-term financial, operational, and reputational damage. All right, let's move on to the weak and negative risk culture and then actionable strategies to enhance BIP's risk culture. As we see on weak and the negative risk culture, first of all is cost over safety, which BP prioritize on saving time and money over safety engineering decisions. And moreover, unsafe practices normalized, alarms were disabled, and faulty equipment was ignored, showing that risky behavior became a routine. And a poor risk communication, critical warnings like Halliburton several gas flow problems were overlooked and not fully read. Unclear accountability, multiple contractors and unclear roles created, and in the gaps might oversight and responsibilities. And misaligned incentives that staffs were rewarded for speed and the cost savings, encouraging shortcuts and unsafe decisions. Actionable strategies to enhance BP's risk culture. First of all, strong leadership communication. Leaders must prioritize safety in actions, decisions, and communication to the shift to the culture. And then incentive that reward safety. Bonuses and promotions that should be tied to the safety compliance, not speed and cost savings. Better risk communication, which a clear reporting and stop work authority ensure hazards that are taken seriously and escalate immediately. Standardize safety procedures, apply consistent safety rules across all BP sites and contractors to avoid a confusion and risky behavior, and a variation. Training and competency development, which regular safety training and a scenario-based drills help workers recognize how to respond to the risk. And lastly, build a non-blame learning culture which encourage reporting a mistake and near misses so the organization can learn and prevent future disasters. Thank you.
Hi, my name is Kim Risha, matrix number 292184. Today I'd like to talk about BP's British Petroleum's cultural flaws, influence on decision, and catastrophic outcomes. First of all will be cost cutting over safety, which prioritize money and schedule over engineering integrity. Risks were treated as acceptable costs, not something to be engineered up. One of it is the BP's engineer skipped the cement bond lock (CBL), which is the critical test to confirm the cement barrel was solid to save time. Besides, they chose the cheaper long-string casing with fewer safety barrels against gas influx. Consequences: these choices led to a fundamentally compromised well integrity and inevitable failure. Second, normalization of defiance, accepting known shortcuts and flaws as business as usual. Slowly accepting technical flaws and warnings because they got away with it before. One of the examples is BP's engineer downplayed issues with the Opticam software used for cement modeling, knowing the results were questionable. Besides, they dismissed the concerns about the rollout preventer, BOP, reliability and maintenance. Consequence: an accumulation of unresolved technical flaws that render the final safety mechanism, the BOP, unless when needed. Third is regulatory ambiguity reinforcing expediency. The core idea is exploiting unclear rules for speed and cost savings. Unclear, unified safety standards create gaps, which BP used as opportunities for speed. They selectively interpreted safety norms, always choosing the least rigorous and cheapest option. They exploited regulatory gaps between different agencies like the MFS and OSHA, and therefore expediencies over precaution, systematically eroding all safety margins because there was no clear regulation prohibiting the shortcuts. Prioritization of expediency over preventive engineering. The flaw: doing something fast always won over doing it right. Ignore severe gas warnings, use partial mass circulation instead of full bottoms up, therefore weak cement integrity and compromise safety layers. Decentralization, structure and fragmented accountability. Risk was shared, but responsibility was diffuse and blurred. Site managers acted autonomously, safety versus cost role were blurred on the rig. Therefore, diffuse responsibility and weakened oversight at a critical moment. Lastly, leadership-driven trust and overconfidence. Leadership set a tone that delays were unacceptable and technical superiority was assumed. Delays treated as failures, concerns were not escalated due to overconfidence. Warning signs were suppressed and risks escalated unchecked. Therefore, these six flaws forms the cultural foundation that made the disaster inevitable. Culture is a critical, measurable safety factor in high-risk operations. Thank you.
Assalamualaikum and a very good day to everyone. My name is Nur Shafika binti Badrul Salam. My number is 9297542. Today I will be presenting an evaluation of BP's risk culture using the IRM ABC model which stands for attitudes, behavior, and culture. I will explain how weak risk attitudes led to unsafe behaviors and eventually form a dangerous safety culture that contributed to the Deepwater Horizon disaster. Attitudes, cost, and speed over safety. Let me begin with attitudes, which represent the underlying mindset of the organization. At BP, leadership placed a strong emphasis on cost control and fast project delivery instead of prioritizing safety. This shift was especially clear under the CEO at the time, Tony Howard. He once said that the company's assurance process are killing us, which showed that he believed safety checks were slowly down operations. Because of this attitude, BP started to prefer faster and cheaper options, even if they were less safe. A clear example can be seen in the Macondo well project, where BP chose a long string casing design instead of a safer linear tieback options. Although the safer method will have added time and cost, it will have reduced risk. But management prioritized speed. They also ignored risk models and warning signs from technical specialists. In simple words, BP's mindset was let's move fast and save money first. Safety can come later. This attitude became the foundation for the unsafe behaviors that followed. As next, we move to behavior, which reflects what people actually did in daily operation. Because management valued speed, employees on the rig often cut corners and skip important safety steps. For example, BP cancelled the cement bond lock test, which is a crucial test to ensure the cement job is strong enough to prevent gas leaks. They also did not fully circulate the drilling mud, which will help detect gas migration. Even worse, the alarm system on the Deepwater Horizon was placed on quiet mode, meaning important warnings will not sound loudly. There were also serious communication failures when engineers like Greg Walls raised concerns about using only 6 centralizers instead of the recommended 21. Management rejected the suggestion simply because it will take more time. These behaviors show that we call normalizing defiance, where unsafe shortcuts start to feel normal because nothing bad has happened. But eventually, these behaviors created the perfect condition for disaster. Finally, we look at culture, which is the overall environment shaped by these attitudes and behaviors, weak processes, safety, and broken oversight. According to the Baker report, BP did not have a strong company wide focus on process safety. Many employees felt that safety was not a core value, but just a box to tick. Different BP sites are operated almost like separate islands with inconsistent safety practices. Production targets were rewarded more than safety performance, which made employees feel pressured to prioritize output over protection. BP also failed to learn from past accidents such as the 2005 Texas refinery explosion. This shows a culture of complacency where the company became too confident and ignored lessons that could have prevented the Deepwater Horizon tragedy. In short, BP's culture became one where speed and production mattered more than safety. This made the organization unable to manage the high risk environment of deepwater drilling. To conclude, when we analyze BP using the IRM ABC model, we can clearly see how attitudes prioritize cost and speed, behaviors reflected unsafe shortcuts and ignored warnings, culture become a weak, complacent, and disconnected from process safety. Thank you for listening.